This is the summer packet no calculator part. Given fx equals this, find f of -2. We plug -2 in. Equals 13. Same thing, f of x plus 2. We just plug in x plus 2 squared minus 2 times x plus 2 plus 5. So we replace x using x plus 2. Now we just need to simplify it. Plus 4 minus 2x minus 4 plus 5. Last one, fx plus h. We just replace x using x plus h. We plug everything in, similar to example 2. We simplify it. Problem 4. Given the graph on the right, f of 0 equals -4. f -1 equals -3.4 or 3.5. So it's an approximation. f2, if you look at the function, both are circles. So the function doesn't exist at that point. fx equals 2 when x equals what? So x equals 2. This is the y value equals 2. You have two answers. One is -5, or you have 3. f4, when x equals 4, it's a circle here, so it's undefined, or DNE. f -2. So the dot is here, so f -2 equals -2. f3 equals 2. fx equals -3. So we draw a line here. That's a y value. The intersection, one's here, one's here. So x equals 1.5 and -1.5. The equation of the line meets the following conditions. Use point-slope form. So given slope and the point, y minus y1 plus 2 equals 3 times x minus 4. Same thing. That means -5, 7, x plus 5. So given 2 points, 4, -8, -3, 12. First we find the slope, rise over run. 12 plus 8 over -3 minus 4, 20 over -7. So any point you want to pick, or y plus 8 equals. Write the equation of the tangent line in the slope point form. Given line tangent to fx at x equals 1. So when x equals 1, y equals -1. That's a point. We have to find the slope of this line. So this line goes through this one. Rise over run. So the slope equals -2 over 1. So point slope formula. Okay, number 9. The line tangent to fx at x equals -2. So -2, +2, 0, 4. So the slope equals 2 over 2 equals 1. So the equation y minus 2 equals m times x plus 2. Number 10. Which choice represents the slope of the secant line? So it's 2, f2, and 7, f of 7. Rise over run. 11. Which choice represents the slope of the secant line shown here? It's x, f of x. When x equals x plus 2, f of x plus 2. So rise over run. fx plus 2 minus f of x over x plus 2 minus x. Number 12. Same thing. X, fx. and x plus h, fx plus h. So the equation will be Rez overrun, fx plus h minus fx over x plus h minus x. Number 13, which of the following statements is true? F of 2 equals 0. F of 2 is not 0, so number 1 is wrong. F5 and F negative 1 both equal 0, so that's right. So F5 and F negative 1 and F negative 4, all of them equal 0. So we have 3 factors. Factors of fx will be x minus 5, x plus 1, and x plus 4. You have 3 factors. Number 14 to 16, domain range and horizontal asymptotes and vertical asymptotes. So domain is for x. So if you look at the graph, x cannot be negative 1 and cannot be 1. So the domain will be negative infinity to negative 1, negative 1 to positive 1, and 1 to infinity. And range, the range will be from negative infinity, top, to it will reach here. And then there's a gap. So we'll start from 3, not included, to infinity. So look at the y direction. Horizontal asymptote, so y equals 3. And vertical asymptote, x equals negative 1 and x equals 1. Number 15, the horizontal asymptote, y equals 0. Vertical asymptote, x is negative 1 and x equals 3. So the domain will be negative infinity to negative 1, negative 1 to 3, and 3 to infinity. And the range, if you look at the graph, in the y direction, it has everything, negative infinity to positive infinity. Number 16, the horizontal asymptote. There is no horizontal asymptote. Vertical asymptote, x equals negative 2. Domain, x cannot be negative 3 and negative 2. So domain negative 3, negative infinity to negative 3, negative 3 to negative 2, and negative 2 to infinity. And the range is very easy to make a mistake here. Okay, the range, a lot of students will exclude 3. Don't forget, this branch will keep going. So the range will be negative infinity to positive infinity, include everything. Number 17, which of the following function has a vertical asymptote, x equals 4? So if we look at the denominator, first of all, it cannot be cancelled. So if you look at 2, x minus 4 is cancelled. So there's no vertical asymptote. There will be a hole here. This is not right, this is not right. D, x plus 6 over x minus 3, x minus 4. So D is right. The denominator equals 0, so there are 2 vertical asymptotes, x equals 3 and x equals 4. Number 18, this function, which of the following statement is true? So first, let's factor it. So it's x minus 2, x minus 3 over x plus 2, x minus 2. Because x minus 2 is cancelled, so x equals 2. There will be a hole there. Vertical asymptote, x equals 2. That's not right. That's a hole. fx has a vertical asymptote, x equals negative 2, which is right. The denominator equals 0. Has a horizontal asymptote when y equals 1. Horizontal asymptote, x go to plus minus infinity. Because they are the same degree, so this equals 1. So number 2 and number 3 are right. D. Number 19 to number 24, simplified using rational exponents. This equals x 3 over 5 plus 2x to the power of 1 over 5. This part is the same thing as 2x to the first, then take the fifth root. X plus 1 to the 1/2. If we have a square root, we don't have to write down 2 there. This one gives us negative power. Negative 1/2 minus 2 times x to the negative 1. This one 1/4 times x to the negative 3 plus 1/2 times x to the 3/4. 4 1/4 times x to the negative 1/2 minus 2 times x plus 1 to the 1/2. In number 25 to number 30, you write the negative power to a fraction. So 1 over x to the 1/2 square root x cubed, and 2 you can ignore it. Number 26, 1/2 negative power we move to the denominator. Number 27, negative power 1 over radical x, 1 over square root of x plus 4, 1 over x squared plus square root of x, 2 times 1 over x squared plus 3 over 2, 1 over x. Number 31 to number 42 are the trig values of special angles. Sine power 6, 1/2. Cosine power 4, radical 2 over 2. Sine 2 pi, 0. Tangent pi, 0. Secant power 2 equals 1 over cosine power 2. Cosine power 2 equals 0, so it's undefined here. Cosine power 6, square 3 over 2. Sine power 3, radical 3 over 2. Sine 3 power 2, negative 1. Tangent power 4, 1. Cosecant, 1 over sine. Sine power 2 is 1, so 1 over 1 give us 1. Sine pi equals 0. Cosine power 3, 1/2. From 43 to 45 are basic trig equations. So from 0 to 2 pi, given an equation, what's the special value? Sine of x equals 1/2. Sine of what give us 1/2? As we know, sine is 30 degrees in radians. Pi over 6 and 5 pi over 6. Tangent of x equals 0. Tangent of what give you 0? 0. Tangent of 0 equals 0. Tangent pi and tangent 2 pi. Cosine of x equals negative 1. From 0 to 2 pi, there's only one value. Cosine pi equals negative 1. 46 to 54 involve exponential function and logarithm functions. So these equations, we have to know e to the 0 equals 1 and ln1 equals 0. The first one, e to the x equals 1. So x equals ln1 equals 0. 3 to the x equals 3. E to the x equals 1. X will be ln1 equals 0. E to the 2x equals 1. So 2x equals ln1. 2x equals 0. So x equals 0. ln x equals 0. We apply exponential. So x equals e to the 0 equals 1. So ln x, 3 minus 3 give us 0. So x e to the 0 equals 1. 3x equals e to the 0 equals 1. So x equals 1/3. X squared minus 3x equals 0. So we factor x out. X equals 0 or 3. This one, we have e to the x in common. Factor e to the x. So e to the x equals 0 or 1 plus x equals 0. E to the x equals 0, no solution here. So that's impossible. E to the x is always positive. So x equals negative 1. That's the only solution. E to the x, remember the graph, goes through 0, 1. So e to the 2x minus e to the x. So e to the 2x, we can write it as e to the x squared minus e to the x. We can factor e to the x out. So this equals 0 or this equals 0. So not possible here. So e to the x minus 1 equals 0. E to the x equals 1. X equals ln1 equals 0. Number 55 to number 63 are trig equations. Number 55, sine of x equals 1/2. X is from 0 to 2 pi. So sine x equals 1/2. In the first quadrant with reference angle, basically, reference angle equals 30 degrees, pi over 6. So sine is positive, you have two solutions, first quadrant and second quadrant reference angle days. So your final answer will be pi over 6 and 5 pi over 6. So basically 1 here, 1 here. Reference angle pi over 6, reference angle pi over 6. Number 56, cosine equals negative 1. It's a very special angle here, so x equals pi. Cosine x equals square root of 3 over 2. Cosine is positive, 1 in the first quadrant, 1 in the last quadrant. With reference angle, cosine what give you square root of 3 over 2? Cosine pi over 6. So pi over 6 here, pi over 6 here. So our final answer, pi over 6 and 11 pi over 6. So 2 sine of x equals 1/2. So sine x equals negative 1/2. Sine is negative, you have 1 here, 1 here. With reference angle, when we solve reference, we don't have to look at the negative. Sine what give you 1/2? As we know, sine pi over 6. So all the reference angle is pi over 6. So in third quadrant, 7 pi over 6, and last one, 11 pi over 6. Cosine x equals radical 2 over 2. So two angles, 1 here, 1 here. With reference angle, pi over 4. So answer, pi over 4, 7 pi over 4. Last one, cosine x over 2 equals square root of 3 over 2. We have to be careful because x is from 0 to 2 pi. So x over 2 will be from 0 to pi. So from 0 to pi, that means in the first two quadrants, cosine of what give you square root of 3 over 2? Cosine pi over 6. X over 2 equals pi over 6. So x equals pi over 3. Be careful here, the condition here. Tangent of x equals 0. As we know, tangent equals sine over cosine. Cosine cannot be 0, so sine, it's the same thing. Sine x equals 0. X equals 0, pi, and 2 pi. Because both 0 and 2 pi are included, so that's our answer. Sine 2x equals 1. So this one, because x is from 0 to 2 pi, 2x is from 0 to 4 pi now. So sine of what give us 1? As we know, sine pi over 2. And we can keep adding 2 pi to pi over 2. Give us 5 pi over 2. Adding another one will give us 9 pi over 2, which is out of range. So 2x equals these two values. So x equals pi over 4, we just need to divide 2. So x over 4 will be from 0 to pi over 2. Now x over 4 should be pi over 3. So x equals 4 pi over 3. Because this condition, we only have one solution here. From 64 to 68, there are domain range problems. We have to be a little bit familiar with the graph of each function. So square root of function, that's a graph look like. Parabola, x equals 3. Open up our n, x, e to the x. This one is a little bit tricky. If we square both sides, we have square equals 4 minus x squared. Basically, x squared plus y squared equals 4. It's a circle. However, y has to be positive, so it's only the semicircle on top of x-axis. So the domain here, 4 to infinity. Range, 0 to infinity. Domain here, negative infinity to positive infinity. Range, 0 to infinity. Domain, 0 to infinity. Range, all values. Domain, negative infinity to infinity. And the range will be 0 to infinity. Last one, domain, negative 2 to positive 2. Range, 0 to 2. From problem 69 to 80 is simplified all the expressions. This equals x to the 1/2 over x equals x to the 1/2 minus 1 equals x to the negative 1/2. E to the ln x base E cancelled, give us x. E to the 1 plus, based on the property, e to the first times e to the ln x. E to the first times e to the ln x is x. So final answer, e times x. And keep in mind, e is a constant, don't get confused. E is a constant approximately 2.7. ln 1, 0. ln e to the 7. 7 times ln e, the power is out. So equals 7 times 1, give us 7. Log 3. So log 3, 1/3. We can write as 3 to the negative 1. Negative 1 log base 3 of 3 give us 1. So it's negative 1. So this is 1. Number 75, log base 1/2, 8. Because the base is a fraction, we don't like that. We are going to use our change base formula. So because 1/2 and 8, both of them are related to 2, base 2. So we are going to use base 2 to the 8 over base 2 to the 1/2. Because 8 is 2 to the 3rd, so that gives us 3. 1/2 is 2 to the negative 1, give us negative 1, so it's negative 3. ln 1/2. This one equals negative ln 2. We have to use our calculator for this one. Number 77. 27, because we have a 3 here, we are going to write 27 as 3 to the 3rd. So this will be 3 squared equals 9. Number 78. We multiply the two constants, 20. Same base, a. So the power, we just need to add them together. So 20 times a to the 6, that would be 4 plus 9. 20 times a to the 13 over 6. Number 79. We have negative powers. When we have negative powers, we have to flip it. So numerator will move to the denominator. Denominator will go up to the numerator. So 4x, 12, keep it. So y to negative 2, here. X to the negative 1/3 goes up. Y to the 5th power, 3. X to the, combine them, 4 over 3. Y's 5th, y cubed. Final answer. Last one equals 4 to the 3 over 2 times, we can distribute the power in. So this equals 2 squared. A to the 5 over 3 times 3 over 2. This is 8 times a to the 5 over 2. Number 81 to number 90 is compound functions. F plus h1 equals f of 1 plus h of 1. So f of 1, when x equals 1, y equals 7. h of 1, 6 equals 13. K minus g 5 equals k of 5 minus g of 5. So k5 plug in, 5 squared plus 5 minus g of 5, square root of 5 minus 3. So it's 30 minus radical 2. F of h3, so first we have to evaluate h of 3. So h of 3 equals 2. This problem becomes f of 2. f2 equals 4. G of k7, so first we evaluate k7. So k7, 7 squared plus 5. 49 plus 5, 54. G of 54 equals square root of 51. H of 3 equals 2. G of G9, so first G of 9 give us square root of 9 minus 3, square root of 6. So G of square root of 6, we plug it in, equals square root of 6 minus 3. F inverse of 4. So if this confuses you, we let this equals m, for example. That means f of m equals 4. F of what equals 4? M equals 2. Number 88. Function k of x equals x squared plus 5. This one didn't pass the horizontal line test. So there's no inverse function. So for function to have inverse function, it has to pass the vertical and horizontal line test. K of g of x. That means we are going to replace x in the k using g of x. So this will be g squared plus 5. Now we just need to plug g inside. X minus 3 squared plus 5 equals x minus 3 plus 5 equals x plus 2. Last one, g of f2. F of 2 given f of 2 equals 4. G of 4, we plug 4 in, give us 1.